So this next unit that we're starting is about functions, a little bit of stuff on functions in general, and then we're going to look at quadratic functions specifically, and another type of function that's a little bit new specifically, but it's not very hard. It's a lot like a quadratic. But we're going to take a few days to talk about functions in general. Today we're going to do some definitions and talk about, like I said, a couple things just in general about functions, and talk a little bit about domain and range. It's pretty straightforward, pretty simple stuff today. And the stuff we get into tomorrow is just notation, so it'll be a little bit new, but it's not too bad either. Anyway, so that's what's coming. So this unit is kind of about quadratics and functions, and we mean by functions, we mean like graphs, that kind of thing. And then the next unit is also going to be about quadratics, but has a different take on it. So anyway, definitions. A relation is a set of ordered pairs. What do we mean by a set? We just mean, it means like a group, like it's literally just, you got a bunch of them and you're considering them all at the same time together for something. This is often written as an equation. So an equation is a nice way of writing a relationship or a relation that like has an infinite number of points, and so you can't write all of them. Or even if it doesn't have an infinite, if it's got a lot of points, you don't want to write them all out. You'll see a little bit what I mean later when we look at the examples that you've got in front of you, but it's not nice to write out a list of points. So if there's a relationship, then we write it as an equation. But that's still a relation, because an equation is still just giving us a bunch of ordered pairs. You know what I mean by an ordered pair? We mean like x, y is an ordered pair. And you know from grade 9 and grade 10 that if you have an equation, y equals something, you can plug in x and get the y. And then you've got the x and the y ordered pair, right? So kind of the same idea. So when we're talking about a relation, that's just a word that we use where we're talking about a bunch of points on the graph. They might form a line or some other pattern, or they might just be literally points. The domain is the set of all x values of a relation and the range is
y values.
Yeah. The set of all y values, all possible y values of a relation. So we're going to do, so the only thing about domain and range is the notation, the way we write it is important, and you have to get used to it. You have to write it the right way. We have like basically no tolerance for writing it the wrong way. So that's what you're getting good at today and over the next few days when we talk about domain and range, is you just have to practice and get to the point where you write it properly. And don't mix them up. Domain is the x's and range is the y's. Somehow you got it, because some people mix that up and then they just get every question's wrong, and you might not lose all the marks because you might be right just in the wrong spot, but it's kind of a big deal. So that's kind of what one of the important things you can get out of today is really nail down which one's domain, which one's range, and how we write it. That's one of the things from today. And a function is a special kind of relation. Okay, so it's a relation where for every x value there is a unique y value. So by unique, we mean only one y value. And again, this is just a definition. So there's like, somebody says, I don't get it. Well, there's not anything to get. It's a definition. That's what a function is. And we're going to do some examples to illustrate exactly what that means in a moment. But this is what a function is. Okay? And so you just have to remember what it means for something to be a function. I can have an equation of something that could be a graph or whatever, but it's not a function. So not every equation is a function. I'll give you a couple of examples of things that are functions. I don't know that you have to write these down. Y equals 3x minus 1. That's a function, turns out. Y equals x squared plus 5x plus 6 is a function. Okay? They're also equations. They're also graphs. Those two happen to be functions. Here's one that's not a function. X squared plus y squared equals 9. Anybody know what that is? You probably saw it briefly in grade 10, but like maybe one day and that was it and you didn't do very much with it. It's a circle. Oh, sorry. I didn't actually let anybody answer, but it's a circle. If you graph that with like technology, that would be a circle. Okay, so circles are not functions, but the top one is a straight line, and usually straight lines are functions. And the second one there is a parabola or a quadratic, and they are functions. So those two are functions. The red one is not. So why do we care about functions? Because I'm going to be straight with you a little bit here. In grade 9, you talk a bit about domain and range. And then in grade 10, you actually have seen this before pretty much exactly. In grade 10, you talk about what a function is and how you tell if something's a function. And you talk again about domain and range with a little bit more depth. But I don't think you really understand, like nobody ever explains why we care about domain and range and why we care about something being a function. And that makes it harder to learn when you have no idea what the point of it all is. So why would we care? And domain and range, to be honest, will be hard to really understand the purpose of that. I'd be willing to talk to you about it if you're very curious, but it's a little bit tricky. Like there's a couple of courses that you could take in grade 12 where you start to understand why it's important, but until then, it's kind of hard to see why we care about domain and range. But like I say, turns out they're actually pretty important. But why do we care about functions? This is something that you can understand, I think. Why do we care about functions? Does anyone remember what makes something a function? We haven't even talked about that yet. Oh, well, unique one y value. Why does it matter that if we're looking at a relation, that every x value, there's only one y value? Why is that important? And by the way, the reverse doesn't have to be true. You can have how am I going to say this? Two x values can have the same y, but two y values can't have the same x. So it's only one of those things that's true. Does anybody remember what this actually means? Okay, so what it would mean, this is what we're going to do in a minute. It's really easy to understand what this means graphically. So I'm just going to do an XY graph. There's X, there's Y. And I'll put a bunch of points on it. Okay? And if 2 points are directly above and below each other, that's the same X that has two Y's. Right? This X value here could be this or could be that. Therefore, that set of points is not a function. Why does that matter? Hard question. Okay, so let me ask you this. What kinds of things do we represent with equations? Like, why do we even care about equations? I'll give you a simple example. This is from grade 9. A plumber costs $50 to show up at your door and $75 per hour after that. Okay, the familiar relationship, you've heard of that kind of thing before. You can imagine paying a plumber to come and fix your toilet or an electrician or something coming into your house. Does that make sense? Yeah? So that relationship can be represented with an equation, a formula, so that if they're in your house for 3.5 hours, you can work out exactly how much that would cost, right? You would multiply and add and get the total cost that you would have to pay. Like, that's the point of math, right? People will always wonder, why are we doing this? But when it comes down to it, that kind of thing is the reason why we have math and we do math, is for those kinds of instances. And obviously there's more complicated ones. But you can imagine this easy one with the plumber. $50 per hour, or sorry, $50 to show up at your door, and then $75 per hour. Plus parts, plus tax. Right? So you could calculate the total cost for any number of hours given that formula. What if that formula wasn't a function? So I've had him in my house for 5 hours, and I don't know if I pay him that or that. How do you decide which one it is? Do you kind of see where I'm going with this? So functions are a special kind of relationship or a special kind of like equation or formula where when you put in an x, you get out a y, and that's what you have. Because if you put in the x and you get out 4 or 5 different y's, how would you know which one is right? Or the one that you want, or whatever it is? You wouldn't. So this is why in math, it's important to us that we know when something's a function. So when I put in the x and I get my y, I know that's the only y, and I know how much I pay the plumber, basically. So anyway, that's not necessarily something you need to know to be able to do any of the stuff we're going to do, but it is, to me, interesting and maybe gives a little bit of context for what we're doing. We're actually going to flip to the back and do example 2 first. I know that seems strange, but the pictures wouldn't fit on the first page, so I put them on the back page, but I want to talk about this one first. Because I think the visual component of what makes something a function is the easiest way to think about it. And then we'll go back and do the other ones that are lists of points. People also, if we do example 1 first, people think that that's what domain and range always looks like, and some people, for whatever reason, never get past that and keep making the mistake, so I don't want to fall into that. Okay, so the vertical line test, this is really, really important. This is the visual that you really need to have. If any vertical line passes through more than one point of your relation, then that relation is not a function. So the vertical line test will determine if something is not a function. So let's take a look at this first one. First of all, it says state the domain and range of each relation below and state whether or not each is a function. Okay, so we're going to do domain first. And here's how we write the domain. We write it in this, I'm sure it's going to be strange to you. Well, you've seen it before, but it's a weird way, but it's very specific. Okay, we start with a curly bracket, or it's called a brace bracket. And this is how in mathematics we show sets of things. And a domain is a set, so this is what we do. So this is a very common standard. And if you remember, domain is the possible x values. So I'm just going to list them off. So this one looks like -4. And they don't have to be in order, but it's easier to make sure you got them all. It's easier for me to read them and for us to kind of look at them and be the same. And probably the answers in the back of the book or whatever will be in order. So it's kind of best to do it in order, but it's not a matter of right or wrong. This one's at -3. But we're only listing the x values. This one's at -1. I've got 2 that are at +1, but I only have to list 1 once. I don't have to list it twice. That would be weird. Because a domain, like I've already said, 1 is one of the values. Why would I say it again? Okay? And then looks like +4. And then I've got them all. So I have 1, 2, 3, 4, 5, 6 points, but only 5 possible x values. Does that make sense? Kind of? Domain is the possible x values. Range, same way. Except this is possible y values. So I've got -3, -2, -1. I've got 2 at -1, so I only list it once, and 2 at 2. So I only list that once. Normally, domain and range isn't just a list of numbers. For today it will be, but after that, rarely will it be. So this is what I don't want you to get, I don't want anybody in here to, think this is how we always do domain. We list out that's not usually the way it works. So all the other ones we're going to look at won't look like this, and that's more normal. Okay? But our first example, we're just listing out the possible x's and possible y's. So is this a function?
No.
No, because I've got 2x points that are on top of each other. And all it takes is that one. All the other ones are fine, but those two are on top of each other. One's on top of the other. So this is not a function. Okay? Any questions? Does it seem weird? Or does it seem okay? Okay, let's try the next one. We got to do the domain and the range and then determine whether or not it's a function. So this is a more typical graph. It's a special kind of relation that is a straight line, so there's a relationship between all the points. The relationship looks like I take one of the points, I subtract 2, and that'll give me the other point. You don't need to worry about that, but it turns out that that's what it looks like. I take one of them, I subtract 2, that gives me the other. Okay, but that's not what we're doing right now. So it's a straight line, and what do the arrows mean? Because people love to forget arrows on their axes and their lines and that kind of thing, but it turns out arrows are really important. Sarah, what do arrows mean? It means that the line keeps going. It doesn't stop just where the end of the line stops. The line keeps going forever. So what are the possible x values for this relationship? And this is where you've got to be able to visualize, is that line ever going to stop and then the x's after that don't belong there? Like some people would go, okay, so it's -2, -1, 0, 1, 2, 3, 4, and 5. And they would list them. That's wrong. Because it's not just, watch this, it's not just 4 and 3, but it's all the points in between, which there's like an infinite number of points between them. All the decimals, all the fractions, everything between them, those are all parts of the relationship too. It's not just a bunch of points. So what do you think?
Don't you put like XER?
Yeah, and what does that mean though? Yeah, that's fine. So what are the possible x values?
Like every real number.
Yeah, everything. X can be, but just say it with natural language. Like, we're going to talk about how we write it, the notation. But what you should be thinking is the natural language, which is, what can x be? Is there any value that x won't be for this relationship? No, x will be everything because it's going forever to the negatives and forever to the positives and includes 0 and includes anything. And how do we say x can be anything? We say x is an element, so it's a rounded capital E of the real numbers, and we do 2 lines with an R. And it seems wonky, and people are like, can I just do it my way? No, because all of those symbols mean something very specific in mathematics. That's how we talk about the real numbers. It's called a double bar, capital R. You write that anywhere in the world and people will know what you're talking about. So it's important. Okay? And same thing for range. And what do we ask ourselves? We ask ourselves, what are the possible y values? Are there any y values that this won't be? What are the possible y values? What do you think? Yeah, y can be anything. Okay, so y is an element of the real numbers. Is it a function? Visualize a perfectly vertical line, a straight up and down line moving along that graph. Is there anywhere that it'll cut it twice? Zach, what do you think?
It's a function.
It's a function. That it passes the vertical line test. There's no vertical line you could draw that will go through it twice. And if you look at the other pictures on the page, you can see the graphs where it will, and you can see the graphs where it won't. And that's like what I would encourage you to do, is look at the examples that are functions and that aren't functions and get a real solid understanding of what they are. Okay, what about this one? Let's do the domain. What can x be? How far is this going to the left? How far is it going to the right? Ellie, what do you think?
X equal to every number, to -2 in every number.
Above that? Is that the x's or the y's though?
No, I mean like more like -2.
Yeah, I understand what you're saying. Good. Alexis? So hold on. The domain is, why do you say that? So this arrow is pointing to the left, sort of, like it's diagonal, but it's going to the left. So this part will go to every negative x value, and this one will go to every positive x value. So ignoring the up-down part of the graph and just visualizing the left-right, it looks like x is an element of the real numbers. Okay, why don't you continue with the range? Why is that different?
Because it only goes down to -2, so it's only
Very nice. So both of the sides of the graph are pointing up. So it has a lower limit. So we still include this part. Y is an element of the real numbers. And then we write a straight line, which means such that. And then we say y is greater than or equal to -2. Very good. And that needs to have every single one of those parts. It needs the open brace bracket, the curly bracket. Y is an element of the real numbers written like that, straight line such that, and then y is greater than or equal to -2. If you wrote it like this, -2 less than or equal to y, I would say that's really weird and hurts my eyes, but it's not exactly wrong. It's just not the way we usually say it. We usually start with the y in this case. Y is greater than -2. That's still saying y is greater than -2, but it's just saying it backwards. If you said this, that's wrong because you're saying y is less than -2, and that's not true. Or same thing if you said this, -2 is greater than y, that's wrong. Those are both wrong because the sign's pointing the wrong way. So that's the other thing you have to get used to, is which way the sign points. Some people get it, some people don't. You have to figure out a way to memorize it if it doesn't make sense to you. To me, it's super easy. The big end points at the bigger thing. That's all it means. For some reason, some people have a hard time with that. Okay, let's try a few more. Let's keep on going. Oh, wait, did we miss that one was a function or not? Yeah, so is this one a function or not? I can draw a bunch of horizontal lines that cut it in two places, but that's not the test. It's a vertical test. So what do you think? Sarah? It is a function. There's no x that will give me two y's, so it's a function. What's the domain of this one? Where are those, there's arrows on the arms, where are those arms pointing? Is it going to stop somewhere going to the left or stop somewhere going to the right, or does it go everywhere? Go ahead and write it if you think you know. What do you think? Pearson, do you have any ideas?
Maybe X.
Like, what you want to think about is there an x that it's never going to get to? We got to remember something about parabolas. It looks like they start going straight up, but they never do, right? They do keep going out. So will it go out both ways forever? It will. That means all x's are in. All x's are good. Both of those sides to the left and to the right are going out. So that means x can be anything. And how do we write it? We write it like this. X is an element of the real numbers. Range. Is there any restriction on the y's? Y has to be bigger than -4 or equal to, it touches -4, I think, right? We agree on that. So it touches -4 and it goes bigger, but never goes below. So we start with y as an element of the real numbers such that y is greater than or equal to -4. Is it a function? Yeah? Good. Function. Passes the vertical line test. Okay, next one. Domain. What are the possible x values? Or like, even if you tell me, you don't have to tell me what to write. Tell me in your own words. Oh, x will always do this, or x won't do this. That's what you should be able to do. And then if that's the best you can do right now, then we work on writing the notation. But I want you to think about what it means. Jada, what do you think? Any ideas? What about x? We're just thinking about x right now.
X, ER, and then when x is greater than -3.
Very nice. So x will never be smaller than -3. That's what you're saying. Exactly. X will never be smaller than -3. And you said it right. X is an element of the real numbers such that x is greater than or equal to. All these are greater than or equal to. I should flip one around to -3 in this case. And range?
Y every real number.
Yeah, y can be anything. Very good. No restrictions. The top bar is going up forever. The bottom bar, or arm, or whatever you want to call it, is going down forever. So all y's are in. Very good. Any questions before we keep going? Next one's a little bit different. We write it a little bit different, and it's a very different kind of shape. There's a circle for you. Oh, wait, I keep forgetting. Is that one a function? Why don't you stop me? It's not a function because it fails a vertical line test. I can draw all kinds of lines through it where there's two y values for the x value. So this one is not a function. Very good. All right, now to the next one, domain. What are the possible x values? Start at one side of the graph and go to the other. Can it be -6? Can it be -5? Can it be -4? Can it be -3? Like, ask yourself those questions. Where does it start? Where does it stop? Just the x's. Ben, do you have any ideas? Sarah, what do you think?
X is larger than -5.
5 is here. So what number is that we're actually at? 4. So x goes from -4 to 4. You said it great. It's larger than -4, but it's smaller than +4. From -4 to 4. That's the natural language way of saying it. How do I write it? X is an element of the real numbers such that you start with the smaller one. Again, we always do left to right. So you start. This is the only case where you start with the number. And I do less than or equal to x, less than or equal to +4. So x is between the two numbers that it goes between. -4 is less than x, which is less than 4. You can't write it the other way. Can't flip it around. Because positive 4 is not less than negative 4. So don't do that because that's really wrong. And what about the range? Zach?
Would it be the same thing?
It's going to be the same thing, but with y, exactly. It goes from negative 4 to 4. Okay? Any questions on that? We got a few more to do here. And then we'll go back to the other page. The other ones are easy. What about this one? You have a question?
Yeah, I do.
Go ahead.
About the circle one, why is it greater than negative 4 and less than 4?
For domain or range, which one are you talking about? For both of them? Okay, and we also forgot to do a function again, so we can go back and do that while we're talking about this. Very good. Because the x values can go from negative 4 to positive 4. Where will it be 1? Up here. Where will it be negative 2? Over here. But the graph somewhere goes through that x value. Right? But it's never going to be 5. And it's never going to be 6. So it goes from negative 4 to positive 4, and that's it. That's where all the x values are in that domain. See how they're all in that confined space? And every other spot, and then same vertically, they're all in that confined space. When I find any y value, they'll all be smaller than 4 and bigger than negative 4.
So negative 5 we consider less. Like we make it it's always less and less.
Negative 5 is smaller.
Okay.
So that's why negative 4 is less than x. We're saying negative 4 is less than x. So x can't be negative 5 because then that would be wrong. And is this one a function? Not a function. Good. Okay, now we move on. What about this one? This is a straight line, no arrows, and whether it has dots or not doesn't matter. Now sometimes on a worksheet or a quiz or a test, something doesn't have arrows and they're supposed to be there just because the computer program doesn't put the arrows in. So usually it'll be obvious and you'll know when there's supposed to be arrows or not. If ever you're not sure, you should ask. But in this case, like there's dots. So the arrows aren't just missing. There's no arrows on this. So what is the domain for this one? What are the possible x values? Will it ever get to negative 5? What does it stop at going this way? Ellie?
3.
I was doing the other way, yeah. What does it stop at going that way? Negative 4. And Ellie, what does it stop at going the other way?
3.
At 3. And look at how that line crosses every x in between those two values. So this is x is an element of the real numbers such that negative 4 is less than or equal to x less than or equal to positive 3. Just going back up to that first example of the dots, notice how we didn't say x is an element of the real numbers for that one. Because this one is just those dots and no other values, but a line means all those points and every point in between. So it means like negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3, and every decimal and fraction between them, right? That's what that means. Okay, and what about the range? So think about, like, you can draw a box. It's never going to go below that line. It's never going to go above that line. So what's the minimum value it's going to go to? To me, it looks like negative 2. What's the maximum value that it can go to? looks like positive 3 again. And this one is a function. Next one, let's try to get through the next couple quickly so that you can get to your own practice. What's happening? What's different about this one? Yeah, it's stopping on one side, but it's going on forever on the other side. So this one has a minimum x, but no maximum. How do we write that? X is an element of the real numbers such that x will always be greater than or equal to negative 4. Because it starts at negative 4 and goes forever. And what about the y's? It has a minimum, but it goes up forever.
Y is every real number.
Very nice. Y is greater than or equal to negative 2. Exactly right. Hi. And this one's a function as well. And last one, this one's a function. Domain. So this one is the only one that looks like this, I guess. It has a maximum x. Look, it's never going to go above that. It's never going to go that way. So x is an element of the real numbers such that, how would you say this with natural language? X will always be?
Equal to or less than 3.
Yeah, less than 3 or equal to 3. Very good. Less than 3. So we say x is less than or equal to positive 3. And the range, y is an element of the real numbers such that, looks the same to me, y is less than 3. Questions on that? Okay, very quickly, let's go back up to these ones. There's a few of these in the practice. They're really uninteresting to me. I don't even know why I don't even know if it's any point doing them, but let's do them anyway. But remember, usually this is not how you write domain in range, because usually we're talking about graphs, functions, lines, and it's more interesting. So what's the domain for this one? The possible x values. If you're given a list of points, you just list the x values. So it's 1, 3, 5, and 7. And the y values are 2, 4, 7, and 2 again. Yeah?
Why do you write the 2 twice?
I don't know why we wrote the 2 twice. Good catch. You don't need to. Although I'm going to erase in a second. I'm going to leave it there for a minute. What does it mean when we have that 2 twice? I've got 1 and 2, and I've got 7 and 2. And so when I visualize that, I can see that's fine. So this is a function. What I don't want is 2 x's. 2 y's is fine. So this is a function. And Ellie, you're exactly right. We didn't need to write the second 2. Okay, B. So the possible x's, negative 2, negative 1, 0, 1, and 2. And the range, I'm not going to write these in like order from smallest to biggest. I'm going to write them in order from left to right because that seems kind of natural. So I've got a 4, I've got a 1, I've got a 0, and then I got a 1 and a 4 again, so I don't need those. So again, what does that look like? It looks like -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. That's like a parabola, and that's fine. It's fine if the y values repeat. So this is still a function. -2, 4, 5, -2 again, 3, 3 again, 6, and 7. So I've got -2 and 3, and I've got 4 and 3, I've got 5 and 6, and I've got -2 and 7. So see how I had the x's repeating? This is not a function. Turns out domain and range is actually something that's kind of important. It's a little bit hard to see, but it is. And whether or not something is a function is also very important. That hopefully you saw a little bit of that earlier. And that's it. Any questions?